Welcome to my channel Chemistry Not Mystery. You can also visit my website chemistrynotmystery.com. Today we are going to learn all about oxidation number and its calculation. So watch this video till the end to learn what is an oxidation and what is reduction, what do you understand by oxidation number, and how to calculate oxidation number. Oxidation and reduction reactions are opposite to each other. Let me elaborate it. In general, oxidation is defined as the addition of oxygen. So reduction can be the removal of oxygen. Oxygen is an electronegative element. So we can define oxidation as the addition of electronegative element. Then reduction will be the removal of electronegative element. Removal of hydrogen is also oxidation. So the reduction will be the addition of hydrogen. Hydrogen is an electropositive element. So we can define oxidation as the removal of electropositive element. So the reduction will be the addition of electropositive element. But the most applicable definition of oxidation is the increase in oxidation number and reduction is the decrease in oxidation number. Let's try to understand these definitions with some reactions. Carbon plus oxygen gives carbon dioxide. Here oxygen gets attached to the carbon and we know that the addition of oxygen is oxidation. So here carbon gets oxidized. Now see the next reaction. 2H2S plus oxygen gives 2S plus 2H2O. Here oxygen gets attached to the hydrogen, so hydrogen gets oxidized in this reaction. But what about the sulfur? Here hydrogen is removed from the sulfur and the removal of hydrogen is also oxidation. So here sulfur also gets oxidized. Now examine the next reaction. Magnesium plus fluorine gives MgF2. Here neither hydrogen is removed nor oxygen is added. So how do we decide? Here electronegative element fluorine is added to magnesium. And we know that the addition of electronegative element is also oxidation. So here you can say magnesium gets oxidized. Now try to understand the other definition of oxidation with another reaction. 2Na plus Cl2 gives 2NaCl. Here electronegative element chlorine is added to sodium. That means sodium gets oxidized. Let's observe the change in oxidation number of sodium and chlorine. Here the oxidation number of chlorine changes from 0 to -1 and the oxidation number of sodium changes from 0 to +1. That means there is an increase in oxidation number of sodium and we know that the increase in oxidation number is the oxidation. In this way also we come to the same conclusion. None of the definition contradicts the other. You can use any of them. I hope now you understand the different definitions of oxidation. Now come to the reduction. I am going to explain the reduction with the same set of reactions. Let's see. In the first reaction, if we change the direction, you will see carbon dioxide gets dissociated to carbon and oxygen. Here oxygen is removed from the carbon and we know that the removal of oxygen is reduction. So here carbon dioxide gets reduced. Now come to the next reaction and observe it in the reverse direction. Hydrogen is added to sulfur and we know that the addition of hydrogen is reduction and oxygen is removed from water, which means sulfur and water both get reduced. Let's observe the next reaction in a reverse direction. Here magnesium gets attached to the fluorine and the addition of electropositive element is the reduction. So fluorine gets reduced. Now come to the last reaction. Here the oxidation number of chlorine changes from 0 to -1 and you know that the decrease in oxidation number is reduction. So here chlorine gets reduced. In short, you can remember oxidation as the addition of oxygen or the removal of hydrogen or the increase in oxidation number. and reduction is just opposite of oxidation. So it will be the removal of oxygen or the addition of hydrogen or the decrease in oxidation number. You might ask, how do I know the oxidation number? Here I will tell you the way to calculate the oxidation number of any element in a molecule. First, try to understand what is an oxidation number. It describes the number of electrons that an atom either gains or loses in order to form a chemical bond with another element. It can be any real number. Negative oxidation number represents the number of electrons gained by an element, and positive oxidation number represents the number of electrons lost by an element. To assign the oxidation number to an element, you have to remember some rules. Like if an element is in free state or in its standard state, then its oxidation number will be 0. For example, oxidation number of sodium metal will be 0. Oxidation number of hydrogen in H2 will be 0 because hydrogen exists as a gas, a diatomic molecule. So H2 is the standard state of the hydrogen. Like O2. In O2, the oxidation number of oxygen is also 0 because O2 also exists as a diatomic molecule. Oxidation number of first group elements in compounds is always +1. Oxidation number of second group elements in compounds is always +2. Oxidation number of hydrogen when it is bonded to electronegative element is +1. But if it is bonded to an electropositive element like first group or second group elements, then its oxidation number will be -1. Oxidation number of fluorine in compounds is always -1. Oxidation number of oxygen in compounds is mostly -2. Oxidation number of any ion is equal to the charge on it. For example, the oxidation number of Fe+2 ion is +2, or the oxidation number of O-2 ion will be -2. Let's try to find the oxidation number of any element in a compound. In HCl molecule, we know that the oxidation number of hydrogen is +1 as it is bonded to the electronegative chlorine. Let the oxidation number of chlorine as X. Here you need to learn the next rule, that the algebraic sum of oxidation number of all the atoms in a neutral molecule is always equal to 0. So we get the equation 1 plus X equal to 0. And after solving it, you will get the value of X is equal to -1. So the oxidation number of chlorine will be -1 in this compound. Now find out the oxidation number of sulfur in SO2 molecule. We know that the oxidation number of oxygen is mostly equal to -2. And here 2 oxygen atoms are present. So you have to multiply -2 by 2. And let the oxidation number of sulfur as X. SO2 is a neutral molecule, so the sum of oxidation number of both the elements will be 0. So you will get the equation X plus -2 multiplied by 2 is equal to 0, and after solving it you will get X is equal to +4. Now find out the oxidation number of nitrogen in HNO3 molecule. We know that the oxidation number of oxygen is mostly equal to -2 and the oxidation number of hydrogen is +1, and let the oxidation number of nitrogen as X. So you will get the equation +1 plus X plus -2 multiplied by 3 is equal to 0. And after solving it, you will get X is equal to +5. But how do you find the oxidation number of any element in an ion? For that, you have to remember that the algebraic sum of oxidation number of all the atoms in a polyatomic ion is equal to the net charge of the ion. Let's try to calculate the oxidation number of oxygen in OH- ion. We know that the oxidation number of hydrogen is +1 as it is bonded to the electronegative oxygen. And let the oxidation number of oxygen as X. Here you will get the equation X plus 1 equal to minus 1 because there is minus 1 charge over the ion. On solving the equation, you will get X is equal to minus 2. Now find out the oxidation number of sulfur in SO4 minus 2 ion. We know that the oxidation number of oxygen is mostly equal to minus 2. And let the oxidation number of sulfur as X. You will get the equation X plus minus 2 multiplied by 4 is equal to minus 2. And on solving the equation, you will get X is equal to plus 6. Now find out the oxidation number of nitrogen in NH4 plus ion. We know that the oxidation number of hydrogen is plus 1 as it is bonded to the electronegative nitrogen. And let the oxidation number of nitrogen as X. You will get the equation X plus 1 multiplied by 4 is equal to plus 1. And on solving the equation, you will get X is equal to minus 3. So far, we have seen the positive and negative oxidation numbers. But do you know that the oxidation number can be fraction too? Let's try to find out the oxidation number of carbon in C3O2 molecule. Let the oxidation number of carbon as X. You will get the equation X multiplied by 3 plus minus 2 multiplied by 2 is equal to 0. And on solving the equation, you will get X is equal to plus 4 by 3. Now try to find out the oxidation number of bromine in Br3O8 molecule. Let the oxidation number of bromine as X. You will get the equation X multiplied by 3 plus minus 2 multiplied by 8 is equal to 0. And on solving the equation, you will get X is equal to plus 16 by 3. Let's try to find out the oxidation number of sulfur in Na2S4O6 molecule. Let the oxidation number of sulfur as X. You know that the oxidation number of sodium is plus 1 as it belongs to first group element. So you will get the equation plus 1 multiplied by 2 plus X multiplied by 4 plus minus 2 multiplied by 6 is equal to 0. And on solving the equation, you will get X is equal to 5 by 2. But what do you understand by a fractional oxidation number? Does it mean that the element has shared electrons in fractions? But electron cannot be shared in fractions like a pizza. It is indivisible. So when does an element get a fractional oxidation number? These oxidation numbers are actually the average oxidation number of all the atoms of that element in that compound. Different atoms of that element in such a species exhibit different oxidation states. For example, in C3O2, you have calculated the oxidation number of carbon as plus 4 by 3. But it is an average oxidation number of all the 3 carbon atoms present in it. Out of 3, 2 carbon has oxidation number equal to plus 2 and the middle carbon has oxidation number equal to 0. So when you take out the average of these oxidation number by using the formula sum of oxidation number divided by total number of atoms of that element, you will get plus 2 plus 0 plus 2 divided by 3. Thus you will get 4 by 3 oxidation number. I hope now you understand what an oxidation number and how to calculate the oxidation number of any element in a molecule. But even if you have any doubt, you can post it in the comment box. And don't forget to like and share this video. And to get more such videos, please subscribe to the channel and press the bell icon to get a notification. You can also join my Telegram channel. Thanks for watching. Keep learning. Stay safe.